We have now question number 4 of exercise 6.2. Please make sure that the diagram is well drawn. You draw first the triangle, then you put DE parallel to AC. Join A and D and draw DF parallel to AE. And what is to be proved? BF upon FE is equal to BE upon EC. How to go about it? First of all, in the triangle ABC, the whole triangle, these two are parallel. AC is parallel to DE, which means this side upon this side is equal to FE upon EC. We have this. According to theorem 6.1, if the lines are parallel, the sides are in the correct ratio. In the second one, ABE, we have the second one. DF parallel to AE, and therefore we have BF upon FC is parallel to this number, second one. And therefore BD upon DA, that is again according to theorem 6.1. So first conclusion, second conclusion. From both of these, if you watch here again, these two are common. Both are same. Therefore, these two also have to be equal. That is what we say. From conclusion 1, from 1 and 2, we conclude BE upon AC, BE upon AC is equal to BF upon FC, BF upon FC, exactly what we are expected to prove. Hope it is clear enough. We now go to question number 5, and we have the figure that is there. Let me tell you how to draw the figure. Draw the triangle first. Put any point O. Join OQ, OR and OP. And put another point. Now draw ED parallel to QO and FD parallel to RO and join EF. And then, now look at this. In the triangle POQ, we have this triangle here. These two are parallel. Therefore, PE upon PEQ is equal to PD upon DO. First, according to theorem 6.1. And then we have now second POR, triangle POR, DF parallel OR, therefore PE upon FR is equal to PD upon DO. Again, according to theorem 6.1, lines are parallel, therefore the sides are in the same ratio. Now look at this. You notice that these two are common, and therefore which means these two also will be equal. So we say from 1 and 2, we conclude that PE upon EQ is equal to PF upon FR, and that is our third conclusion. And from the third conclusion, since here, which means the sides are in the ratio, therefore the two lines are parallel. EF is parallel to QR, and that is theorem 6.2. That is, if the sides are in the correct ratio, the lines are also parallel. That is what we are asked to prove. We now come to question number 6 again of exercise 6.2, and how to draw the figure. Draw the triangle PQR. Put a point here. Join point O, join PO, OQ and OR. And then draw AB parallel to PQ, AC parallel to PR, and join B and C. And what are we supposed to prove? BC is parallel to QR. the third side is parallel to the other third side. Now let us proceed with the proof. In first angle POQ, we have these two are parallel. AB parallel PQ, and therefore PA upon PAO is equal to OB upon BQ. First proof, according to theorem number 6.1, lines are parallel and therefore the sides are in the proper ratio. Second, POR, second triangle. AC is parallel to PR and therefore again PA is equal to upon AO is equal to OC upon CR. That is, we have again according to theorem 6.1. If the lines are parallel, the sides are in the proper ratio. So we have first conclusion, second conclusion. And from these two conclusions, again look at this. OB here, OAAP, here again OAAP. These two are common, which means they are the same. This means these two also will be the same. And therefore we have conclusion from point number 1 and point number 2, we conclude that OB upon BQ is equal to OC upon CR. Therefore, which means in the triangle OQR, this triangle, these sides are in the ratio and then sides are in the ratio. Therefore, BC is equal to, if BC is parallel to QR, exactly what we are supposed to be proved. According to theorem 6.2, if the sides are in the proper ratio, the lines are parallel. We now go to question number 7. And question number 7, it is a little tricky because the figure is not given, so you have to draw the figure. But there is no problem. Understand the question. So we have a triangle ABC, and then we have the midpoint of one side, midpoint DE. From the midpoint, we are drawing this line parallel to DE parallel to BC. And what are we supposed to prove? We are supposed to prove that E is the middle point of AC. It bisects the third side, therefore E bisects AC. Now let us proceed to the proof. ABC. In ABC, we are given that these two are equal. Sorry, the DE, this is drawn parallel. DE is drawn parallel to BC, and therefore AD upon AB is equal to AE upon EC according to theorem 6.1. Lines are parallel, sides are proportionate. But we are given that these two are equal. Therefore, AD upon DB is equal to 1. Why 1? Both are equal. You divide the equal number, you get the answer always 1. Both are equal. Since these two are equal, since this is 1, this also will be 1. See here, this is 1. This is 1. Therefore, these two are equal, this also will be 1. Therefore, AE upon EC is equal to 1. Which means that E is the middle point of AC. E is the middle point of AC, which means DE bisects AC, exactly what we are expected to prove. And we have proved it. We have now question number 8. And the question is telling us what to do, and therefore we have to draw the figure. How to do it? Triangle ABC. And then D is the middle point here, E is the middle point here, and we are joining the two middle points. And what are we supposed to prove? DE is parallel to BEC. DE is parallel to BC. Now let us proceed with the proof. D is the middle point of AB. Therefore, AD equal to DB. Both are equal. Which means AD upon DB is equal to 1. and that is our first proof. Similarly, we say E is the middle point of AC, and therefore AE is equal to EC, which means AE upon EC is equal to 1 because both are equal. So when you divide, you get 1. And look at this, both of these are 1. So from 1 and 2, we conclude that AD upon DB is equal to AE upon EC. Now look at this. The two sides are in this correct ratio, and therefore DE is parallel to BC according to theorem 6.2. If the sides are in the proper ratio, the other sides are parallel to each other. What is supposed to be proved? We shall now tackle question number 9 of exercise 6.2, a little different from the previous questions. Trapezium. Two sides are parallel. The diagonals intersect at point O. What are we expected to prove? Here. AO upon BO is equal to CO upon DO. We begin by a construction. Construct EO parallel to DC. The proof. Since AB and DC are parallel, EO and DC are parallel, therefore EO is parallel to AB. Now we look at the triangle. We have the triangle ABD. These two are parallel, therefore AE upon ED is equal to OB upon OD. According to theorem 6.1, parallel lines, proportionate sides. Second, triangle ADC. We have EO parallel to DC. Therefore, once again, AE upon ED is equal to AO upon OC. So we have the second one. Now look at this. We have here AE upon ED, here also AE upon ED. These two are same, which means these two will be equal. 1 and 2 will be equal. Therefore, we say from 1 and 2, we conclude that BO upon OD is equal to BO upon OD is equal to AO upon OC. And that is same as what we meet here, that is AO upon BO is equal to CO upon OD, according to theorem 1. What we are doing here is only transposing these numbers, that's all. And therefore, we have proved what we are expected to be proved. Here we have question number 10, similar to but opposite of question number 9. Attention, you are supposed to prove that the quadrilateral is a trapezium. Therefore, first of all, make sure that you draw the trapezium with AB and DC parallel. Then, what do? We begin by a construction. Construct EF through the point O parallel to AB. Now, since AO, it is given AO upon BO is equal to CO upon DO. Therefore, from here, we just transpose the letters, the sides, and we get this AO upon CO and is equal to BO upon OD. Transposition which is normal. We come to the proof. In triangle ABD, these two are parallel, and therefore EA upon ED is equal to BO upon DO. So this is our first proof, and we have the second. Now you look at this. In the first, we have these two, and here the same thing, which means AO upon CO is equal to AE upon ED. And that's what we are telling. From 1 and 2, we conclude here. This is equal to this, our conclusion. And that is same as telling, therefore, these two EF is parallel to DC because these two are coming from this triangle. And consequently, ABCD is a trapezium. Why? EA parallel AB parallel DC because EF parallel also DC. So we are now using the reverse of theorem 6.1, that is, from the proportionate side the lines are parallel, therefore we have a trapezium. That's all.